Okay, welcome back to the next part of the video. Now, before we get going with this part, I actually loaded up a different scenario because I wanted to illustrate kind of what's going on here as we leave the Earth, or excuse me, as we leave the Moon and head back to Earth and try to arrive in plane with the ISS. I'm here with the DX7, the inline client, so that I can have that Orbit Lines add-on in use, and I just think there's something that I can show here that will help really drive home the point of why we need to leave the Moon at a specific time in order to get in plane with the ISS. So let me select this other vessel that I've got in this scenario, and we'll kind of come outside and take a look. And I've got this vessel in orbit around the Moon. It's in a fairly high orbit, and that's just to help exaggerate the orbit lines. You can see here, well, I don't have orbit MFD up, but we're at a 3,000 plus kilometers, so we're out there quite a ways, and we're in an orbit around the Moon that has us passing over Brighton Beach, because as we leave Brighton Beach, any direction that we decide to go, no matter what heading we choose, this will be approximately, we'll be in some form or fashion, we'll be passing over Brighton Beach when we leave our launch pad. Now, currently, the ISS is in a really bad position. Let me rephrase that, because the ISS doesn't necessarily move its position. The Moon is at a really bad place in its orbit around the Earth in order for us to arrive in plane with the ISS. That's a much better way of wording it. Because no matter how we leave the Moon at this point, you can see that we are effectively, sideways to the ISS. The ISS appears from this vantage point to be orbiting, instead of orbiting to where we can see it like this, it's completely sideways. And no matter how we leave the Moon, no matter what heading we choose, no matter what eject orientation we pick, we are never going to get a heading that will allow us to get in plane with the ISS as we arrive back at Earth if we leave the Moon here at this time. And I'll actually show that quickly. Let me jump into the XR2. And I'll quickly go through Transx here. And just set up a return trip to the Earth with the intention of arriving in plane with the ISS, and we'll just see that it won't work. So we have escape to get away from the Moon. Then in stage 2, we need ships. Then we pick ISS as our target. Let me come over to the eject plan and put in the normal amount of negative prograde to get back to the Earth. And as I'm getting in close, I'm actually now going to go over to setup. I can really feel this lag with this client. I'm getting 15 frames per second right now. And for scale to view, we'll pick target. And actually, let me back up. Graph projection, we'll pick plan. And now I'll continue to add in a little bit of negative prograde velocity to go ahead and bring that, that's our orbit line when we get back to Earth. That's where we're going to be. So we'll bring that down to about there. Now that we're close to Earth, we now want to put in our plane change in order to get ourselves, to where we're in plane with the ISS. And what you'll see here is that it just won't work no matter what we do, no matter how much plane change we add in either direction, it just will not work. So I'm adding, 110, it's getting out to 500 at this point. Over 1,000, And you can clearly see that this is not what we need. Now we're at 2,000. That's a pretty ridiculous amount of plane change. So let's just reset it. And we're saying positive did not work. Well, maybe negative will work. So let's try negative. And as we're going with negative, you can see the our angle to Earth is changing, but it's still not getting what we need. We're completely sideways to the ISS at this point. And as we continue to add in negative, we're over 1,000 again, and we're still not even close. And here we are back to 2,000. So no matter what we do, we're never going to get in plane with the ISS as we leave the moon on this day. And you might wonder, why is that exactly? Why can't we get in plane? Well, let's warp time ahead to a better date, and then I think that will help clarify what the problem is. So let's bring up MapMFD, display orbit lines, and by the way, I just switched over to the ISS. Now we're going to target the moon. We're going to just do what we did. Hopefully you saw the other video. And we're going to warp time forward until the moon is basically crossing the orbital plane of the ISS. So let's do that. Let's go forward a little faster. We're getting there. A little bit more. And I'd say we're about there. So let's go back to real time. I'm going to go ahead and zoom in a little bit just to make sure we're pretty close to where we need to be. Yeah, we could even go forward a little farther than this, but it'll be okay. That's probably 4 or 5 hours away, so let's go ahead and go forward a little more. And that'll be good enough. That's probably got us at the point where we like to be, which is an hour to 90 minutes from the point where the moon would be crossing the orbital plane of the ISS. Now, let's go back to the moon. And let's jump outside and look at how things look now. Now you can see from this vantage point, the ISS is basically, right in front of us, so to speak. So all we have to do to get in plane with the ISS now is when we lift up off the moon, we just need to adjust our eject orientation so that it matches this line basically. So when we leave the moon, we're going to throw ourselves out sort of over top the moon in a sense. And that'll put us in plane with the ISS as we head back to Earth. And you can see here now that that's actually possible. Whereas when we were, if I can kind of adjust the camera out that way, when we were over here on this side, we were completely sideways to the orbital plane of the ISS and we could never get in plane with it. But when we're over here this way, we can. Okay, so I think that visualization hopefully clarifies, what is going on here and why we have to leave the moon at a very specific time. Okay, so let's go ahead then and exit out of this terrible inline client. And I actually have to close that out completely and start the normal orbiter launch pad and go back to landed at Brighton Beach. That's where we left off.
Warning conditions detected. System reset. External cooling online.
Okay, so here we are now. This is the XR2, and it's landed at Brighton Beach on the landing pad. This was where we left off in the last video, where I brought the XR2 from its orbit around the moon down to the landing pad. And you can, if you remember, it was kind of coasting in on fumes a little bit. I mean, we only got 2.5% left on main fuel. Of course, I could have transferred some of the RCS over in a crunch. And in fact, I probably, if I had it to do all over again, I would know now that I wouldn't have a lot of main fuel, so I would probably transfer over as much RCS as I could just to make sure that I've got all the main fuel that I need. But nevertheless, it worked out, and I tried a couple different landings to see what would work better. And if you remember, I determined that it would be best to go around to the opposite side of the landing pad, the opposite side of the moon, and bring your altitude down so that by the time you get over to Brighton Beach, you're not at a very high altitude, so you don't have to hover as long. And all that hover is kind of what cost us a lot of fuel. But we are here now, and we landed not knowing exactly where the ISS is at. I need to force myself to be careful with that wording. It doesn't matter where the ISS is at. What matters is where the moon is at relative to its orbit around the Earth. And we don't know that, so let's select the ISS. Let me set that up here. So here we're looking, at the ISS at Earth. And we're going to go display, orbit plane, target the moon. We need to find out if we're at a good time, and it looks like by pure coincidence we are exactly at the right time, so we're not going to have to do any time warp at all. That's pretty miraculous coincidence. Let me get zoomed in a lot. Yeah, that's some amazing timing, actually. So zoomed all the way in here at 32, I can see the moon's here, and it's going to pass over the orbit plane of the ISS, and it looks like just an hour to 90 minutes, so it's actually time to set things up and go right now. We don't actually have any time to spend on the moon. If we wanted to, of course, we could stay at the moon for a while and warp time forward until the moon was at the next, crossing over the orbit plane of the ISS on that side, but we don't have anything necessarily to do at the moon, so we'll just go ahead and leave now. Okay, before we leave, though, we need to check out our fuel situation. Now, some rough calculations. Let's bring up burn time calculator, and we've got 204 meters per second of main fuel left. Clearly that's not going to work. So before we do anything, let's open the supply lines and top off our fuel. And looks like we could use some more LOX as well. So let's open the LOX supply line and open the fuel supply lines. Now, of course, we are making the assumption in this video, as we did with the ISS, that once we get to our destination that we have all the resources that we need. So we're making that assumption again here, that now that we're at the moon, that the moon has the capacity to resupply us. In some missions, I actually like to make the assumption that we don't have those resources. So you have to actually plan to go from the Earth to the moon and back to the Earth without ever refueling. But in this video, obviously, we can't do it that way because we're using this version of the XR2 that I've got set up where it burns through fuel much more quickly than the standard. So we have to assume that we have the resources here. Okay, so I'm going to resupply the main, crossfeed over to the RCS so that as we're adding in main fuel, we're topping off the RCS as well. Don't really need to worry about the APU, but might as well top it off. And finally, LOX. And I'm not actually going to top off the locks. It's going to take us maybe 5-6 days. Well, maybe I will go ahead and top it off. Yeah, I think I will, because this version of the XR2 only can only carry 7 days. So I was thinking 14, but it can only carry 7, so we'll just top it off. A little bit of 10x here to speed up this resupply process. And now our main tank is full, and we're actually filling up the add-on modules. So before we top those off, let's see how much estimated fuel we have now. It says we have 3,000 meters per second, but I know that's wrong, because it's not including the fuel mass from the add-on modules. So currently this add-on module is empty. This one is 3447.15. Let's see how much fuel that actually is. 3447.15 minus the weight of the minus the mass, rather, of the tank itself, which is 355.20. So this one's carrying 3,091.95 of kilograms of main fuel at the moment. Let's punch that number in here. And let's actually add in our RCS on top of that. Okay, so we currently have an extra fuel. I need to undo that. I wonder if there's an undo here. Okay, that's annoying. It was 3,800. I'm just going to say it was 3,800. Okay, so we have an estimate 5,400 meters per second of delta V. Now, we know that it's going to cost about 2,000 delta V to get up off the moon and get into lunar orbit. Lunar orbit is about 1,700 meters a second. It's actually a little bit less than that. Plus, we need some extra fuel to hover. So I'm gonna round that off and say 2,000 meters per second. And we know that we're going to use about close to 1,000 meters a second to get back to Earth. That's for the ejection burn. For the ejection burn to leave the moon and go back to Earth, it's going to be something around 1,000. And I'll actually figure it out exactly here in a moment. So that's 3,000. Of course, we're going to use the atmosphere of Earth as a brake, so we don't need any fuel for that. So we've got more than enough fuel already. In fact, I could even return some of that fuel back to the guys here at the lunar base if I wanted to. We don't, because we've got, I would say, at least 2,000 meters per second more than we're going to need. So at the very least, we can turn off the supply lines.
Locks resupply systems offline.
Now let's set up our plan for getting back to the Earth and arriving in plane with the ISS. So we're going to do just what we did before. We're going to go escape, forward on this side, chains to ships, and we want to target the ISS. And while we're here in view setup, we're going to go through the variables here. We're going to change graph projection to plan. For now, at least. We may change it later. Then scale to view works better if we have that at target. And then we'll come over to the eject plan and put in the amount of negative prograde that we need. And it's getting close to that number already, so I'm going to go to a medium setting. And then you can see here that this dashed orange line is now coming down close to the Earth. And what I've found I can actually do, works a little better, is bring it down even lower so that we're, you know, kind of close to the center of the Earth, because as I add in the plane change, it's actually going to send this farther out. So it kind of works better if I start with it already down here. Now we're going to go over to plane change, and I don't know which way I need to go, so I'm going to start with the medium setting, and it looks like positive is correct. You can see that that's got us wrapped around. I don't like the way I'm wording that. It's not that we're wrapped around, or the ISS is wrapped around the Earth. It's that we're in plane with the ISS at this point. Now, if I had gone the other way, if I'd gone negative, then we would see that with, you know, 287, and we're still adding in plane change. We're just adding in a lot of plane change, and we're not getting in plane with the ISS, and we're over 1,000 at that point. So that's how we know we're going the wrong way. So I'm going to reset it, and we're going to go positive because that's what was working. And notice as I'm adding in positive, it's sending my projected orbit here to Earth out. So that's why it is okay to have it a little bit on the low side. Do an adjustment. And I also found in the Moon to ISS video that I did recently that I was erroring too far out when I was saying in the last video it was actually on this side, and I had the orbit line coming out this far, and that was too much. So this time I'm not going to put it out as far as I did last time. Here we're getting close to the point where we're almost in plane with the ISS, so let's go back to prograde for a moment and add in a little more negative. And as we're adding in that negative prograde, we're getting more in plane, bringing the orbit line down. Now we'll go back to change plane. I am not having a good throat day at all. Continue to add in some more positive. And now we've sent our orbit line. It's out here somewhere, so we need to come back over to prograde and bring it down. And that's looking pretty good. We've got a nice circular disc here. This ring, blue ring, would suggest that we're in plane with the ISS. And last time, you know, like I said, I thought that I would need to push my orbit line, my projected orbit, back at Earth way out, and it was too much. So this time I'm just going to leave it roughly here, because I know it's going to come down a little bit, but it's not going to come down as much as I thought it would. So we'll leave it here roughly at the orbital altitude of the ISS. That's probably a little too low, but we'll just go with that. Now there's one other thing I want to do, and that is I want to arrive at Earth when the ISS is fairly close to my position. Right now it's not. Right now this is saying that the ISS would be over here and we would be over here. I also found last time that I did this that I want the ISS to be closer to my position than it was before. Before, I think I had the ISS out here, and that was way too much. It needs to be much, much closer to your position. We will be going faster than the ISS when we get back to the Earth by several thousand meters per second, but it's going to be short-lived. We're not going to be traveling, you know, at close to 11 kilometers per second for very long, because we're going to hit the atmosphere and slow down. So we want the ISS to probably be in front of us, but not by much. And the way we can adjust that, most likely, is with outward. Just a little bit of outward. You can see that's basically throwing ourselves out a little bit farther and adding to the amount of time that it's going to take us to get back to Earth. And by adding in just a little bit of extra time, it's allowing the ISS to catch up to us. You know, you can sort of think about it. If you were driving a straight line, you know, down a highway, or you know, through a flat area, the fastest way to get there is a straight line. If you want to purposely slow yourself down a little bit, you can drive a little bit out to the side, which is going to add more distance. And since you're adding more distance, it's going to take longer to get to your destination. So by adding in a little bit of positive outward, that's basically what we're doing. We're saying that our orbital path to get back to Earth is going to be something like that, but we're going to add a little bit more out to it in order to purposely make it take longer to get back to Earth. And we're not talking about a lot of time. We only need to add, the ISS was over here, and we want it to be over here, so we're only talking about, 30 or 40 minutes of additional time that we want to add to our flight path. And probably something like that. Yeah, in fact, I'll just go with that. I won't try to anticipate, where the ISS needs to be in front of me. I think as I get closer, or as I'm traveling back to the Earth, I can make those adjustments as needed. So we'll just assume at this point that we just want to get as close to the ISS as we can. Something like that. Okay, so that has us set up. Hopefully all of that makes sense. You know that we have a good date because we chose the ISS and we brought up map MFD and looked at where the moon was at relative to the orbital plane of the ISS, and we know that this is a good date. We know that we are in plane with the ISS as we leave the moon, and we know that the ISS will be close to our position when we get back to the Earth. And we know that our orbital altitude at the Earth is going to come down a bit. So even though we're saying here that we would be at an orbital altitude of about 300 and some odd kilometers, actually probably closer to 400, that's going to come down, and that's actually what we want, because we want to hit the atmosphere, at 70 kilometers or thereabout. So the fact that that's going to come down a little bit is okay. Alright, now let's go over to this side, and here in View Setup, we're going to go to Graph Projection and change that to Plan again. And then we're going to go to the Escape Plan, set our PE distance at a number that's going to just be 20 kilometers greater than that number. So we're going to set our PE distance to 1.758, or 1.768 works as well. And there we have that. Now we go to the eject orientation, and we need to swing this white line, which is the line of nodes. We need to swing it around so that it is straight over top of the green line, which is our position on the moon. And if we have it here in this place, in this location, then we're going to go, this is saying that we're going to go all the way around the moon, almost one full orbit, before we hit the ejection point and take off. And one full orbit around the moon is something like 100 minutes. Even though the moon's much smaller than Earth, the fact that we're traveling much slower, we're only 1,650 meters per second roughly, so it takes longer to orbit the moon than it does to orbit the Earth. But we're going to want that time because if we come back over to the ISS for a moment, we bring up Map MFD. Unfortunately didn't keep all that information. We target the moon. If we zoom in, let me zoom out actually and get... Yeah, you can see the moon isn't quite over the orbital plane of the ISS yet. So by leaving the moon and going around one full orbit, that will give the moon, another hour or so to get to that point, and that's what we want in this case. Alternatively, we could go the other way, and I'm just curious to see how close it is to the eject point. So if we left the moon here on this side, we've got about a quarter of an orbit, so that would only be about 25 minutes from this point to that point. And that would be enough time for me to set everything up. But it wouldn't, I don't think it would be it wouldn't give me quite the time that I want for the moon to travel through space to get closer to that orbital plane of the ISS. So I'm going to go around, I'm going to go out the long way. Okay, there we have that. We've got our eject orientation where we need it. Heading of 75.5 degrees roughly. And we've got everything set up. So I'm going to go ahead and Control S here. Yep. And we'll end this video and pick it up in the next part where we'll lift up off the moon and get into orbit and then head off back to Earth. If you like this part of the video, go ahead and leave a comment down below, and I will see you in the next part. Let me rephrase that, because the ISS doesn't necessarily move its position. The moon is at a really bad place in its orbit around the Earth in order for us to arrive in plane with the ISS. That's a much better way of wording it. Because no matter how we leave the moon at this point, you can see that we are effectively, sideways to the ISS. The ISS appears from this vantage point to be orbiting, instead of orbiting to where we can see it like this, it's completely sideways. And no matter how we leave the moon, no matter what heading we choose, no matter what eject orientation we pick, we are never going to get a heading that will allow us to get in plane with the ISS as we arrive back at Earth if we leave the moon here at this time. And I'll actually show that quickly. Let me jump into the XR2. And I'll quickly go through TransX here. And just set up a return trip to the Earth with the intention of arriving in plane with the ISS, and we'll just see that it won't work. So we have escape to get away from the moon. Then in stage 2 we need ships. Then we pick ISS as our target. Then we come over to the eject plan and put in the normal amount of negative prograde to get back to the Earth. And as I'm getting in close, I'm actually now going to go over to setup. I can really feel this lag with this client. I'm getting 15 frames per second right now. And for scale to view, we'll pick target. And actually, let me back up. Graph projection, we'll pick plan. And now I'll continue to add in a little bit of negative prograde velocity to go ahead and bring that, that's our orbit line when we get back to Earth. That's where we're going to be. So we'll bring that down to about there. Now that we're close to Earth, we now want to put in our plane change in order to get ourselves, to where we're in plane with the ISS. I'm going to come outside and take a look. And I've got this vessel in orbit around the moon. It's in a fairly high orbit, and that's just to help exaggerate the orbit lines. You can see here, well, I don't have orbit MFD up, but we're at a 3,000 plus kilometers, so we're out there quite a ways. And we're in an orbit around the moon that has us, passing over Brighton Beach. Because as we leave Brighton Beach, any direction that we decide to go, no matter what heading we choose, this will be approximately, we'll be, in some form or fashion, we'll be passing over Brighton Beach when we leave our launch pad. Now currently the ISS is in a really bad position. Okay, welcome back to the next part of the video. Now before we get going with this part, I actually loaded up a different scenario because I wanted to illustrate kind of what's going on here as we leave the Earth, or excuse me, as we leave the Moon and head back to Earth and try to arrive in plane with the ISS. I'm here with the DX7, the inline client, so that I can have that Orbit Lines add-on in use. And I just think there's something that I can show here that will help really drive home the point of why we need to leave the Moon at a specific time in order to get in plane with the ISS. So let me select this other vessel that I've got in this scenario, and we'll kind